Hello everyone, welcome to my channel. This is 𝐻𝐫𝐸𝐿, and in today's video, we are going to build and deploy a full stack e-commerce application called Shopverse on Amazon EKS from scratch. This is a complete end-to-end project that covers everything a DevOps engineer does in real-world environments. We will start by understanding the application architecture, then provision our AWS infrastructure using Terraform. After that, we will containerize our application using Docker. Next, we will create Helm charts for Kubernetes deployment and build a fully automated CI/CD pipeline using GitHub Actions. Finally, we will set up traffic as our Ingress controller so that users can access the application from the internet. So the technologies we will be using in this project are React and White for the front end and Go with the Fiber framework for the backend and MySQL as our database and Docker for containerization and Kubernetes on AWS EKS for orchestration. Terraform for infrastructure as a code, and Helm for packaging our Kubernetes manifests, GitHub Actions for CI/CD automation, and Traffic as our Ingress controller. So before we start, make sure you have an AWS account with admin access and a GitHub account, and the following tools need to be installed on your local machine like kubectl, Helm, Terraform, AWS CLI, and Docker. And you need to have a basic understanding of Docker and Kubernetes concepts that will help you to follow along more easier, guys. Okay. So now let me give you an overview of what Shopverse is. So Shopverse is a fully functional e-commerce web application where users can browse products, add items to their cart, place orders and manage their wish list. It also has user authentication with JWT tokens, so users can register, log in and have their own personalized shopping experience. So the application follows three-tier architecture. At the front, we have React frontend, and in the middle, we have our Go backend API, and at the back, we have our MySQL database case. Okay, so let me explain you each one. So the frontend is built with React 18 and White as a build tool. We use React Router for client-side navigation and Tailwind CSS for styling and Axios for making API calls to our backend. And the application has six main pages like home, products, cart, orders, wish list, and an authentication page for login and registration. In the production, the build front end files are served Nginx inside a Docker container, guys. Okay. So now let me explain you about backend service. So basically, this backend service is written in Go using the Fiber framework, which is one of the fastest HTTP framework available. We use Chrome as our ORM for database operations and JWT for authentication, and the backend exposes REST API endpoints for authentication, protects cut operations and orders. It also has L-check endpoints at /health that Kubernetes uses to monitor the application. And the backend includes CORS, middleware to handle cross origin request for the front end guys. Okay. For the database, we use MySQL, which stores all our application data, including users, products, cart, items, and orders. In Kubernetes, MySQL runs as a stateful set with a persistent volume so that other data survives even pod restarts. When the application starts for the first time, the database is automatically seeded with 28 sample products, guys. Okay. So now let me explain you about infrastructure Terraform scripts. So you can directly come down and you can directly open this Terraform directory. So inside this Terraform directory, you can find all the Terraform scripts, guys. Okay. So let me open this main.tf file and let me explain you about this directory first. So basically, we are using Terraform to provision everything on AWS. This is called infrastructure as a code, meaning we define our entire infrastructure in code files and Terraform creates it for us. And this approach is repeatable, version controlled, and emulates manual efforts, guys. Okay. So here is what we are going to provision. First, we will create a VPC with two public subnets and two private subnets across two availability zones. And the public subnets are for our network load balancer and NAT gateway. And the private subnets are where our EKS worker nodes will run. We will also create an internet gateway for public internet access and NAT gateway so that our private nodes can pull Docker images from internet without being directly exposed. Next, we will provision an EKS cluster. So here EKS is Amazon's managed Kubernetes service where AWS manages the control plane for us and we only manage the worker nodes. We will create a node group with two T3 medium instances that run in our private subnets. We will also set up required IAM roles and policies so that EKS can manage AWS resources on our behalf, guys. Okay. Next, we will create three ECR repositories. So here ECR is an Amazon's container registry where we can store our Docker images, and we need one repository for the front end and one ECR repository for the back end and one ECR repository for Helm chart, which we also store as an OCI artifact in ECR, guys. Okay, and our Terraform code is organized into modules. So the main.tf file at the root calls three modules like VPC, EKS, and EC2. For each module has its own main.tf file, variable.tf file, and output.tf files. And this modular approach keeps our code clean and reusable, guys. Okay. So now let's look at how we containerized our applications. So we use Docker multi-stage builds for both the front end and back end, which is best practice for creating small and secure production images. So first let me open front end Docker file. So you can directly find this front end Docker file inside this front end directory. Let me open this Docker file. So this front-end Docker file, we have two stages. So in the first stage, we have Node 18 Alpine image as our builder. We copy our package.json and run npm install to get all dependencies, and copy our source code and run npm build, which creates an optimized production build in the dist folder. And in the second stage, we use Nginx Alpine image. We copy the build files from the first stage into Nginx HTML directory, and we also copy our custom Nginx config file which handles spa routing with the try files directory. We also run APK upgrade to patch any known security vulnerabilities in the base image. And the final image is very small because it only contains Nginx as our static files, none of the Node.js build tools case. Okay. So now let me explain you about this backend Docker file. So you can find this backend Docker file inside this backend directory. So let me open this Docker file. Now for the backend Docker file, we also have two stages. So we use a Golang 1.24 Alpine image. We also copy Go module files and download dependencies and copies the source code and build the static binary using CGO enable equal to 0 and ID flags -w and -s to stop debug information, which makes the binary smaller. And in the second stage, we use Google's distoless static image. So here distoless images contains only your applications and its runtime dependencies, nothing else case like a no shell, no package manager, no other programs. This dramatically reduces the attack surface. So we copy our compiled binary stage and run it as a non-root user for additional security, guys. Okay. So now let me explain you about our Helm chart. So you can find our Helm chart inside this Helm slash Shopverse directory. So let me open this and let me open this chart.ml file, guys. Okay. So before explaining about these YAML files, first let me explain you about Helm. So basically, Helm is the package manager for Kubernetes, just like NPM for Node.js or pip is for Python. Helm packages us to package, configure, and deploy applications on Kubernetes. Instead of managing individual ML files, Helm lets us to use templates with configurable values, and our Helm chart is located inside Helm slash Shopverse directory. It contains chart.ml file with metadata about our chart and values.ml file with the default configuration values, and templates directory contains all our Kubernetes manifest templates, guys. Okay. Inside the templates directory, we have several files. So the frontend deployment.ml and the frontend service.ml defines how our React frontend runs and how other services can reach it. Similarly, backend deployment.ml and backend service.ml do the same for our Go backend. And for MySQL, we have this MySQL stateful set.ml instead of deployment because MySQL stateful set needs stable network identity and persistent storage. And MySQL service.ml, let me open this. So this MySQL service.ml exposes internally and MySQL PVC request persistent storage, guys. Okay. So we also have this config map which stores non-sensitive configurations like database host, database port, and database name, and the front-end origin URL. And we also have this secret.ml which stores sensitive information like database password and MySQL root password and JWT secret. Finally, Ingress ML defines Ingress rules. So through we disabled this since we use traffic Ingress routes, guys, instead. Okay. And there are few key Kubernetes concepts to understand here. So deployment manages stateless applications like our front end and back end, while a stateful set is for stateful applications like MySQL, but needs persistent identity. And persistent volume client requests storage that survives pod restart. And config map stores configuration data, while secret stores sensitive data like passwords. And service provides stable internal DNS names so pod can communicate with each other, guys. Okay. So when we deploy Shopverse applications using Helm, GitHub Actions pipeline is going to override default values with actual image tags and secrets, guys. Okay. So this makes our chart reusable across different environments. Okay. Now let's talk about CI/CD pipeline. So here CI/CD stands for continuous integration and continuous deployment. This means every time we push code to our repository, pipeline automatically tests it, scan it for security issues, and build Docker images and deploys it to our EKS cluster. No manual steps required, guys. Okay. So let me show you the CI/CD pipeline first. So you can directly find that CI/CD pipeline inside .github/workflows inside this deploy.ml file. So basically, this pipeline has four stages that run sequentially. Each stage must pass before the next one starts, guys. Okay. So the first stage is test. So this is the first stage. So let me explain you about this first stage. And in the first stage, we run our Go backend test using Go test and lint for the front end code using ESLint. Before running Go test, we run Go mod tidy to ensure our dependencies are in sync. So this stage catches code errors and style issues early before investing time building images, guys. Okay. And the second stage is security scan. So here we use Trivi. So Trivi is one of the open source vulnerability scanner. We built both our Docker images like a front end Docker image and the back end Docker image. Then next we are going to scan these both Docker images using Trivi for critical and high security vulnerabilities. So if any vulnerabilities are found, pipeline fails and we must fix them before proceeding, guys. Okay. So this ensures we never deploy images with known security issues to the production, guys. Okay. So this is the third stage, which is build and push. So in this stage, first it is going to connect to our AWS using IAM access keys and secret keys. So basically we are storing these IAM access keys and secret keys inside GitHub secrets. Next, it is going to log into the ECR repository and it is going to check for these three ECR repositories, guys. Okay. Like Shopverse frontend and Shopverse backend and Shopverse Helm chart repositories, guys. Okay. So if the ECR repositories are not available, this stage is going to create these three ECR repositories, guys. Okay. So I will show you that later. Next, it is going to build these two Docker images like front end and back end Docker images. It will enter into this front end directory. So basically, this is the front end directory. Inside this directory, we have front end Docker image. So using this Docker file, so it is going to build this front end Docker image, guys. Okay. Next, it is going to tag with latest tag as well as with the GitHub SHA-ID. Okay. Similarly, it will enter into the backend directory. So basically, this is the backend directory and this is the Docker file. So using this Docker file, it is going to build the backend Docker image, guys. Okay. It will build the Docker image and it will tag the Docker image with latest tag as well as with the GitHub SHA-ID. Next, it is going to push these two Docker images to the respective ECR repositories. Like front-end images, it will push to the front-end ECR repository. Backend Docker image, it will push to the backend ECR repository, guys. Okay. Next, it is going to update Helm values.ml file with the new image tags, guys. Okay, for the both front-end and backend Docker images using this set command, guys. Okay. I will show you all this while running this GitHub Actions pipeline. Next, it is going to log in to our Helm ECR repository and it is going to package our Helm chart. So here you can see, here you can find our Helm chart, right? Helm slash Shopverse. So inside this, we have our entire Helm chart, right? So it is going to package this Helm chart and it is going to push this Helm chart to the ECR repository, guys. Okay. So this is the ECR repository for the Helm chart, which is Shopverse-Helm chart. So it is going to push this Helm chart to that respective ECR repository. So this is the third stage. And the fourth and the final stage is deploy. So this is where we actually deploying our EKS cluster. So basically we are going to configure kubectl to connect to our EKS cluster. And we are going to run Helm upgrade command, guys. Okay. So you can find that here. So here you can see Helm upgrade hyphen install. So we are going to run this Helm upgrade hyphen install with our Helm chart from ECR. We are going to override image tags and MySQL password and JWT secret using hyphen set flag. And we also use hyphen hyphen wait with the 300 seconds timeout. So the pipeline waits for all pods to be in ready state. So we also use hyphen hyphen cleanup on fail, which will automatically roll back if anything goes wrong during deployment, guys. Okay. So after the deployment completes, we are going to verify all our resources by running these commands like kubectl get nodes, kubectl get pods, kubectl get stateful sets, kubectl get services. Okay. So using these commands, we are going to verify all our Kubernetes resources, guys. Okay. So I will explain you everything in pin to pin while writing this GitHub Actions pipeline, guys. Okay. And for this pipeline to work, we need to configure 5 GitHub secrets in our repository settings like AWS IAM access key ID and secret key ID for authenticating with AWS. And next, MySQL root password and MySQL password for database and JWT secret for token authentication, guys. Okay. So these 5 secrets we need to provide it inside our GitHub secrets, guys. Okay. Now the last piece of our architecture is Ingress controller. So let me come down, and here we need to open docs. Let me come down, and you need to open this, and let me open this traffic on EKS. So basically our EKS worker nodes are running on private subnets, right? Which means they do not have public IP address. Users on the internet cannot directly reach our application. So we need something that sits in front and route external traffic to our pods. So this is what our Ingress controller does. We are using Traffic as our ingress controller instead of ALB ingress controller. Traffic is Kubernetes native and has excellent support for custom resource definitions called ingress routes. So it also provides automatic service discovery and comes with built-in dashboard for debugging, guys. Okay. So here is how the traffic flow happens. So basically when a user opens our application in their browser, the request first hits the AWS network load balancer, which sits in the public subnets, and the network load balancer forwards the request to the traffic pods running on a private node, and traffic looks at the request path and routes it to the correct service, guys. Okay. So if the path starts with slash API or slash help, traffic sends the request to the backend service. For all other paths, traffic sends request to the front end service, guys. Okay. Once traffic is installed, it automatically creates a network load balancer in AWS. We will create two ingress routes resources, one for the backend and one for the front end. And the network load balancer DNS name is our public entry point to our application, guys. Okay. Next, we are going to create Route 53 hosted zone, and we are going to update Route 53 name servers with the GoDaddy name servers. And next, we are going to install Set Manager using Helm inside EKS for secure HTTP connection, guys. Okay. And this is our final output of our application, and it is deployed on AWS EKS. And we are also accessing it using HTTPS, guys. Okay, which is secure. So let me select this. So this is HTTPS, and this is secure. And this Shopverse application will work similar to real-time application, but this is not a real-time application, guys. Okay. So now let's test this application. Before that, let me connect to MySQL database from AWS EKS, because as I said, MySQL we created as a stateful set inside EKS cluster, guys. Okay. So let me open this EC2. So before that, let me show you our EKS cluster. So here you can see this is the Shopverse EKS cluster. So I created this using Terraform. So basically we created a two-node Kubernetes cluster. And to connect to this EKS cluster, it will create a jump VM. So this is the jump server. And this is the entire networking stack. Let me select this and resource map. And this is the entire networking stack. So this is the VPC, and it is going to create two different subnets, public subnets and private subnets. And inside private subnets, we just hosted our EKS cluster, guys. Okay. And inside public subnet, we just deployed our jump VM, guys. Okay. So now let me open ECR. So this is the ECR. So basically we created three different ECR repositories, one for the front end and one for the back end and one for the Helm chart, guys. So these are the three ECR repositories. So let me come here and let me quickly connect to this jump server, connect, and let me select here connect. And you can directly follow this GitHub README file. Let me open this. Okay. Let me select here Shopverse. So you can directly follow this README file, guys. Okay. So let me connect to the database first. Let me come here and let me do sudo su. Before connecting to this database, let me do kubectl get ns. So inside this Shopverse namespace, it is running all the actual application ports. Let me do kubectl get all hyphen n Shopverse. Okay, so it is going to display all the ports. So here you can see these two are the ports related to backend and these two ports related to front end, and this is the MySQL stateful set port, and this is the backend service, and this is the front end service, and this is the MySQL stateful set service, and this is the backend deployment, and this is the front end deployment, and these are the replica set, and this is the stateful set, guys. Okay, as I said, which is MySQL stateful set. A part of this, we have secrets and config maps also. Kubectl get secrets hyphen n Shopverse, and here you can see Shopverse secret. So inside this, basically we are storing database password and JWT secret and everything. Let me copy this kubectl edit secret and name of the secret hyphen n Shopverse. Okay, it is going to show you everything. So here you can see we are going to store database password, JWT secret, and MySQL root password. Again, we are passing these three values from GitHub Actions pipeline, guys. Okay, I will explain you while running that GitHub Actions pipeline. So now let me do kubectl get config map, and this is the Shopware config map. Okay, so let me copy this name and let me enter into this config map, and let me provide the name of the config map. And inside this config map, basically we are storing database host, database name, database port, and database username, guys. Okay, that's it. Okay, so this is about the config map. Now let me do kubectl get ns, and we are running all the traffic related components inside this traffic namespace. Let me do kubectl get all hyphen n traffic, and here you can see traffic port, traffic load balancer service, and this is the traffic deployment, and this is the replica set, guys. Okay, now let's connect to this MySQL stateful set port. Before that, kubectl get ports hyphen n Shopverse. Now we need to connect to this MySQL port, guys. Okay, so you can directly run this command. So just paste it here. So this is the database password, which is app@1234. So now let me run this command to connect to MySQL shell. Let me come here and let me paste it here. So now it is going to connect to our MySQL shell, guys. Okay, so now let me do show tables. So as I said, we have 5 tables, which is cart items, orders, products, and users. Okay, so let me do select star from users. So here you can see already we have one user registered from our portal, which is demo. Let me open this. So here you can see name is demo, email is demo@gmail.com, guys. Okay, so it is created on this date and on this time frame. So this is the password hash. So let me connect to this demo user, guys. Okay, first. Okay, so let me select here sign in. So initially it will similarly work like a real-time application, guys. Okay, so if you want to create a user account, you need to create a account here, guys, or else if you have an existing account, you can directly use that existing account. So previously, while I was testing this application, I just created a demo user. So this is the email ID. Let me come here and let me paste it here. So the password is demo@123. Let me select here sign in. So here you can see we are inside the demo user. So now if I select this orders, so this user has ordered 2 items. So if you want to check that, you can run these commands, guys. Okay, so view all products. So if you want to view all the products, you can directly copy this command and you can directly come here and you can directly run those command here, guys. Okay, so inside our Shopverse application, basically we have 28 products. So these are all the products, So these are the all the products related to electronics. These are the products related to clothing, and these are the products related to accessories, and these are the products related to food and drinks, and these are the products related to sports, and these are the products related to home and living, guys. Okay, so basically these are the prices, and this is the original price, and these are the rating, and these are the badge. Okay, so it will work similarly like a real-time application, guys. Okay, so let me come here. So if you want to view all products grouped by the category, you can directly copy this and you can directly paste it here, guys. Okay, so here you can see in electronics total we have 7 products. So this is the average pricing, and this is the minimum pricing, and this is the maximum pricing. Okay, so in accessories we have 5, and in clothing we have 4 products, and in food and drinks we have 4 products, and home and living we have 4 products, and sports we have 4 products, guys. Okay, so similarly, if you want to view all orders with customer info, so basically here you can see demo user has ordered 2 products, right? So it is going to display that information. Let me paste it here. So here you can see, so the customer name is demo. So he has ordered total with amount 144 rupees, 114 rupees, guys. Okay, so here you can see 114. So it will work like a real-time application, guys. Okay, so you can keep this project in your resume if you want. If you are a fresher, you can directly keep this project in your resume. Okay, so if you want to view orders items with product details, you can directly copy this and you can directly paste it here, and you can directly run this command, guys. Okay, so here you can see demo user has ordered these 2 products. Okay, so here you can see these are the 2 products. Now let's create a user from this Shopverse. So first let me log out from this account, and let me select here sign in, and here you need to select don't have an account, sign up. So now it will ask a name. So let me provide name like Vijay, and email as vijay@gmail.com. Okay, let me provide like this, and password let me provide vijay@123. Okay, let me select here create. So now here you can see user account has been created, right? So now let me come here and let me run this first command, guys. Okay, so we are going to see this users table. Let me paste it here. So we need to see second user, which is Vijay. So here you can see automatically a new user has been added, guys. Okay, so we created on this date and in this time frame. Okay, so now let me come here and let me order something, guys. Okay, so let me come down and let me open electronics. In electronics we have total 50 items. So let me add this. Okay, so let me add this, and let me add this keyboard also. Now let me order these 3 items. You need to, so you need to select this, and the total price is 221. So if I select here place order, so order will be placed. So now these are the 3, right? So now this database table will be updated, guys. Okay, so let me come down. So view all orders with customer info. Let me copy this and let me paste it here, and let me hit enter. So here you can see Vijay has ordered with total amount 204 rupees, guys. Okay, so let me check this pricing. So here you can see 204 rupees. So this is how it will display everything, guys. Okay, so now let me come here. So now if you want to view complete order breakdown, you can directly copy this and you can directly paste it here, guys. Okay, so here you can see demo user has ordered 2 products. So he ordered premium cotton t-shirt and running sneakers pro, and Vijay has ordered 3 products. So these are the 3 products, guys. Okay, so here you can see these are the 3 products. So this is how you can see the products info by the user also. Now let me come here. So if you want to see current users cart list, you can directly copy this and you can directly come here and you can directly paste it here, guys. Basically it will display all users cart info. So right now we don't have any items inside the cart for both the users. So now let's add few items to the cart and let's see whether it will work or not. Let me add this to the cart, and let me add this to the cart. Okay, so we just added these 2 items, right? So now let me copy this and let me run this command once again. And here you can see Vijay has added these two items to the cart. Okay, so these are the two items. So this is how it will display everything. So similarly, if you want to create third account, you can directly log out from this and sign up, and you need to select here don't have an account, and the second account name is Naresh. So email naresh@gmail.com, and the password is naresh@123. Okay, and here you can see a new user has been created, but he don't have any orders, right? So now let's do one thing. Let's add a few items to the cart. Let me add this bag, and let me add this also. So now let me run this query, guys. Okay, so now Vijay has two orders and Naresh has two orders in the cart. Now we need to see this. Earlier only Vijay has these two items in the cart. Now Naresh user has also two items inside the cart, right? Now let me hit enter. So here you can see Vijay user has these two items inside the cart. Similarly, Naresh user has these two items inside the cart. So this is how it will display everything. So similarly, if I do select star from users, it will display the third user, which is Naresh. Okay, so similarly, if you want to create another user, so you can directly select sign up and add, and the name is Shravani@gmail.com, and Shravani@123, and create. Okay, so here you can see it's created fourth account, guys. Okay, so now I will add only one item now. Okay, I will add this item, and let me check this cart list now. Okay, so let me come here and let me copy this command, and let me paste it here, and let's see the cart list. So here you can see Shravani has added this item to the cart. Okay, so this is how it will display everything. Now let me do select star from users, and here you can see total we have four users. So this is how this application will work, guys. Okay, so this application will work similarly like a real-time application. So if you are a fresher, you can directly keep this resume in your projects, and you can directly explain to the interviewer, guys. Okay, so now I will delete this entire application, and I will start this entire application from scratch, guys. Okay, I will explain you everything from scratch. So before that, let me open this git bash, and let me do pwd. Okay, Terraform state list. It is going to display all the resources which it is created. So I created entire resources using Terraform, guys. Okay, so now, so here you can see all these resources were created. So now I'm going to destroy everything. Terraform destroy hyphen hyphen auto hyphen echo. Okay, so now it will destroy all these running resources, guys. Okay, so now within some after some time this application will not work. Okay, so after deleting all these resources, I will start deploying this application from scratch, guys. Okay, so entire AWS infrastructure was destroyed successfully. So now let's start deploying this Shopverse application from scratch. Initially, you need to clone this GitHub repository to your local, and inside Terraform directory, you can find Terraform scripts to spin up AWS infrastructure. So already I have this repository in my local, so I will use this repository. So let me open this Terraform. So inside this Terraform directory, you can find all the Terraform scripts to spin up AWS infrastructure, guys. Okay, so let me go. So once again, let me give you a small clarity on these Terraform scripts. So basically, our Terraform code is divided into three modules. One is VPC module, and the second one is EKS module, and the third one is EC2 module. So the VPC module creates the networking layer, and this VPC module creates a VPC with the two public subnets and two private subnets, and an internet gateway and a NAT gateway across two availability zones. And EKS module provisions the Kubernetes cluster with managed node group with instance type of T3 medium in private subnets, and IAM roles for the cluster and node, and OIDC provider for IRSA, and the EBS ESA driver for persistent storage. And finally, EC2 module creates an optional jump server in the public subnet for manual cluster access, and all the variables like region, instance type, node scaling are configured through this variables.tf file, guys. Okay, and the state is stored remotely in S3. So CI/CD pipeline can use it, guys. Okay. So basically, you need to create an S3 bucket with any of the name, but that name you need to provide here, guys. Okay, in order to store this Terraform state. So now let's do this everything. Before that, we need to create IAM access key and secret key. So let me create IAM access keys and secret keys. So you need to jump onto IAM tab in search for IAM. Okay, so this is the IAM, and let me select here users, and let me select 𝐻𝐫𝐸 user and security credentials. Okay, let me create access key. Let me select here next and create access key. Okay, so this is the access key. Let me copy this and let me paste it here. And this is the secret access key. Let me paste it here. Okay, so now let me do ls. Let me enter into the Shopverse directory and let me enter into the Terraform scripts. Okay, now let me do AWS configure, and here we need to provide our access key. So basically this is the access key, and next we need to provide the secret access key. So this is the secret access key, and right now I want to create this entire infrastructure on, let me drop down this US East 1 region. So I will come here and I will provide US-East-1. Okay, now let me run this command AWS STS get hyphen caller hyphen identity, and here we need to see our username, guys. Okay, so here you can see it's authenticated successfully. So now let me do AWS S3 LS. So we need to create an S3 bucket, guys. Okay, so here you can see we have three S3 buckets. So let me come here and let me open this S3 tab and let me refresh this. So here you can see we have three S3 buckets. So let me create a new S3 bucket to store Terraform state file. Let me open this and I'm going to create with the same name. So let me copy this and let me select a create bucket, and this is the bucket name, and let me select here create, and here you can see bucket has been created Shopverse Terraform state. So this bucket we are going to use to store our Terraform state file. So now let me come here and let me run this command once again AWS S3 LS. So now it is going to display our S3 bucket, guys. Okay, so here you can see Shopverse Terraform state. Now let me run this command, which is terraform init. So here you can see init has been completed. Now let me do terraform plan. So basically terraform plan command generates an execution plan, and it also provides a preview of the infrastructure changes, and terraform will make without actually applying them, guys. Okay, so let me hit enter. And here you can see plan is 37 to add, meaning it is going to create nearly 37 resources. So now let me run another command, which is terraform validate. So terraform validate command checks the syntax and configurations of your terraform files to ensure they are internally consistent and correct without need to access remote state, guys. Okay, so now let me hit enter. Now here you can see success, the configuration is valid. So finally, let me run this command terraform apply hyphen hyphen auto hyphen input. Okay. So terraform apply command executes the action that are proposed in terraform plan, guys. Okay. So basically it will create entire infra on AWS using terraform scripts, guys. Okay. So let me hit enter. So from now it will take around 15 to 20 minutes to spin up entire AWS infrastructure, guys. Okay. So let's wait for some time. So here you can see plan is 37 to add. So from now it is going to create 37 resources. Before that, let me open this AWS console and let me open this VPC and let me refresh this. So here you can see right now I am on US East 1 region. So here you can see Shopverse VPC has been created successfully, and let me open this resource map. And here you can see VPC has been created, and private subnet has been created, as well as public subnet has been created, guys. Okay, so internet gateway has been created, and route tables are also created. And let me open this. So meanwhile, right now it's creating EKS cluster. Okay, so let me open EKS. Let me search for EKS, and let me open this in a new tab. And here you can see Shopverse cluster, it's in the creating state, guys. Okay, so from now it will take around 15 to 20 minutes to spin up all these resources, guys. Okay, so let's wait for some time. So here you can see nearly after 15 minutes entire AWS infrastructure was created successfully. So now let me do Terraform take list. So it is going to display all the resources which is created by Terraform, guys. Okay, so here you can see it is created all these resources. So now let me check all these resources whether it is created or not. So first let me select here VPC, and let me select here Shopware VPC, and let me select here resource map. And here you can see it's created a VPC. Next, it's created a public subnet as well as private subnet. And next, it's created a two different route tables. One is public route table and the second one is private route table. And for the private route table, it has associated both the private subnets. And for the public route table, it has associated both the public subnets. And for the public route table, it's created internet gateway and it is associated this internet gateway with the public route table. And for the private route table, it's just associated the NAT gateway, guys. Okay. So basically inside the private subnet, we just deployed the EKS cluster, and for public subnets, we just deployed the jump server, guys. Okay. So now let me open EC2 and let me select here instances. And this is the jump server to connect for the EKS cluster, and these two are the EKS nodes, guys. Okay. So it's created with P3 medium. Okay, so now let me select here EKS and let me refresh this page. And now here you can see status, it is showing add to. So Shopverse EKS cluster, let me open this and let me select here compute. So here you can see both the nodes are in ready state. Okay, so now let's connect to this EKS cluster. Before that, let me open EC2 and let me select here Shopverse gem server, and let me select here connect, and let me select here connect. So basically we are using this EC2 instance to connect to our EKS cluster, guys. Okay. Now let me do sudo apt update -y. So it is going to update this EC2 instance. Okay. Now let me do sudo su. Now let me open this documentation and let me install AWS CLI. Let me paste it here. Next I'm going to install this kubectl. Let me paste it here. And finally I'm going to install Helm, guys. Okay, so let me copy this and let me paste it here. Okay, so it's installed successfully. So if you want to install, you can install this Docker, or else this is optional, guys. Okay, so let me paste it here. So if you want all these commands, so basically you can find inside EC2 module. So inside EC2 module, here you can find user data.sh file. So inside this you can find all these scripts to install AWS CLI, kubectl, Helm, and Docker, guys. Okay, so you can find everything inside this GitHub repository itself. Okay, so now let me open this. Let me open this Chrome. Okay, so now it's installed. Let me do AWS hyphen version, and here you can see this is the AWS CLI version. Now let me do kubectl version hyphen client, and this is the kubectl version. Now let me do Helm version, and this is the Helm version. Finally, let me do Docker version, and this is the Docker version, guys. Okay, so everything has been installed successfully. So now we need to do AWS configure, and we need to provide our IAM access keys and secret keys once again for this VM. So let me copy this access key, let me paste it here, and let me copy the secret key ID, and let me paste it here. Now here you need to provide the region, guys. Okay, so currently I created my Shopverse EKS cluster on US East 1 region, so you need to provide this region, guys. Okay, so US hyphen East hyphen 1. Now AWS S3 LS, it needs to display all the S3 bucket, guys. Okay, so here you can see Shopverse Terraform state S3 bucket. So now let's connect to our EKS cluster. So this is the command AWS EKS update hyphen kubeconfig hyphen name. So here you need to provide your EKS cluster name. So this is the cluster name. Let me paste it here. Let me come back. Now hyphen region. You need to provide the region name, guys. Okay, US hyphen East hyphen 1. So now it is going to update the kube config for our EKS cluster. So now let me do kubectl get nodes hyphen wide. Here we need to see our two nodes. So here you can see our two nodes is created and it's in ready state, guys. Okay, so it's created last 12 minutes ago. So now let me do kubectl get ns. So basically here we need to see only kube system namespace pods. Let me copy this. Now let me check pods inside kube system namespace. Kubectl get pods hyphen n kube system. And here you can see inside kube system namespace, all the pods are in running state, guys. Okay. So now let's start implementing our GitHub Actions pipeline. So let me open this file, and this is the GitHub Actions pipeline. So here you can see this is the entire GitHub Actions pipeline. Right now we are going to, right? So the name of the pipeline is Shopverse CI/CD. So basically we are pointing to the main branch, and these are all the env variables we are passing across the pipeline. So basically this is the first stage, guys. Okay, which is test. So basically it runs both backend and front-end tests to make sure nothing is broken before we go further. For the backend, we set up Go 1.24 and run Go mod tidy to sync dependencies when run Go test, which executes all unit tests across every package in the backend, guys. Okay. And for the front end, we set up Node.js 18 and install npm dependencies and run ESLint, which split settings like zero warning allow. If there is even one linting warning, the pipeline fails, and this enforces code quality from the very first stage, guys. Okay. So let me copy this entire first stage. Let me copy up to here and let me open the GitHub repository. So this is the GitHub repository. So now let me select here Shopverse once again, and you need to go to this .github/workflows directory, and inside deploy.ml file you need to provide your CI/CD pipeline, guys. Okay, so GitHub Actions CI/CD pipeline. So let me edit this and let me provide this pipeline. Okay, so now let me select here commit changes. So when you hit here commit changes, automatically it will start running this GitHub Actions pipeline. So let me select here actions, and here you can see it is started. Let me open this. So the first stage is test case. Okay. So meanwhile, let me explain you the second stage. So let me open this file. So basically this is the second stage, which is security scan. And this stage only runs after the first stage passes, meaning test stage passes. So that's where needs test means. And here we mainly focuses on container security. So first it is going to build both front-end and back-end Docker images locally on the runner. And it is going to tag both the Docker images with name scan. And next it is going to install Trivi, which is one of the open source vulnerability scanner by Aqua Security. So Trivi scans both the Docker images looking specially for critical security vulnerabilities. And hyphen hyphen exit code one flag means if any critical vulnerabilities is found, the pipeline fails immediately. And hyphen hyphen ignore unfixed flag skips vulnerabilities that don't have a fix available yet, guys. Okay, so we only fail on things we can actually fix. Okay, and this prevents us for deploying containers without known security issues, guys. Okay, so let me copy this entire second stage meanwhile. So this is the entire second stage. Let me copy this from here. So this is the second stage. Let me open this GitHub Actions pipeline. So here you can see first test stage is green. So now let me select here Shopverse and .github/workflows, and let me select here deploy.ml, and let me edit this. So let me come down and let me paste it here, guys. Okay. So now here you can see, as I said, this is the security scan. So name is security scan. So it runs on Ubuntu for hyphen latest image. So basically it needs test. So meaning after completing this test stage only, it will start running this second stage, guys. Okay. And here you can see first it is going to build front end Docker image. So it will enter into this front end directory, meaning this is the front end directory. It will enter into this directory and it is going to build this Docker image and it is going to tag this Docker image with name scan. Similarly, it will enter into the backend directory and it will build the backend Docker image and it will tag the Docker image with scan. Next, it will install Trivy. Next, it is going to scan this both the Docker images using this Trivy for any of the security vulnerabilities, guys. Okay, so this is about the second stage. Let me select here commit changes and commit changes, and let me select here actions. Now here you can see it is running this pipeline once again. So it is starting from first stage, which is test. So here you can see first stage is green. So now it has started the second stage, which is security scan. And here you can see currently it is building the front end Docker image. Next, similarly, it will tag the Docker image with name scan dash. Okay. After that, it will build the backend Docker image. And now here it is going to install Trivy. And here you can see finally it is scanning the front end Docker image. And here you can see it's generated a small report for the front end Docker image. So this is the report for the back end Docker image. And here you can see, and the security scan is also green, guys. Okay. So this is how it will work. So now let me open this file and let's go to the third stage. And here you can see this is the third stage. So basically this stage is going to build both front-end and back-end Docker images, and it is going to store everything in ECR repository, guys. Okay. So mainly the stage runs after the security scan process, guys. Okay. So here needs we just provided security scan. So this is the security scan stage, guys. Okay. So after completing the stage only, it will run this third stage, guys. Okay. So let me explain you about this stage. So basically for this stage, we just provided name as build tag and push. So basically it runs on Ubuntu image and needs security scan, meaning after completing this second stage, it will run this third stage. And here you can see first it is going to authenticate with our AWS using AWS IAM access keys and secret keys. So basically we need to store this IAM access key and secret key inside GitHub secrets case. Okay. Next, it is going to log into AWS ECR using this AWS IAM access keys and secret keys. Next, it is going to check for these three ECR repositories like Shopverse Frontend, Shopverse Backend, and Shopverse Helm chart repositories. So if the repositories are not available, using these commands, it is going to create these three ECR repositories, guys. Okay. So basically, we are not creating these three ECR repositories using Terraform. So this GitHub Actions pipeline will create these three ECR repositories, guys. Okay. So if the ECR repositories are available, it will skip this stage, guys. Okay. Next, it is going to build both front end and back end Docker images, and it is going to tag with two different tags, which is git ID as well as with the latest tag, guys. Okay. For both front end and back end Docker images. Next, it is going to push this both front end and back end Docker images to the respective ECR repositories, guys. Okay. Next, it is going to update Helm chart values.ml file. So let me open this repository and let me open this Helm and let me open this values.ml. And here you can see it is going to update this image tags, guys. Okay. So let me open this. So using this set command, always it is going to update latest 𝐷 ID images in the Helm values.ml file for both front-end and back-end Docker images, guys. Okay. Next, it is going to cat this values.ml, and next it is going to install Helm. Next, it is going to log into our Helm ECR repository, meaning it is going to log into this Shopverse Helm chart ECR repository. Next, it is going to package our Helm chart, and finally, it is going to push this Helm chart to the ECR repository, guys. Okay. Always whenever this GitHub Actions pipeline is running, it will update images with the latest Git IDs, and it is going to package this Helm chart, and it is going to push this Helm chart to the ECR repository, guys. Okay. So this is the stage. So let me copy this entire stage. Let me copy this. So before copying this, let's do one thing. So we need to store this IAM access key and secret key inside GitHub secrets. So let's do this first. So let me go up, and this is the IAM access key. So let me open this GitHub, and let me select here Shopverse, and let me select here settings. You need to jump onto secrets and variables. So I think already I have provided all these keys. Okay. So here you can see this is the AWS secret access key. So let me edit this. So this is the new one. Okay. So let me copy this access key. Okay. Update secret. Okay. So give me a second. So now here you can see it's updated. So similarly, let me update this secret access key. So okay. So I just updated secret access key. So basically this is the secret access key. And let me update the access key, guys. Okay. So this is the access key, and this is the access key, and region you need to provide as US East one. So basically you need to provide this region, guys. Okay. So you need to provide this region. So if you want to see all these secrets variables, so you can directly open the Shopverse application and directly come down, guys. Okay. So here I just provided everything. So here you can see CACD GitHub Action secrets. So basically you need to provide all these secrets like access key ID. So you need to create a secret with this variable. You need to provide your access key ID. Similarly, you need to create a variable with name AWS secret access key. You need to provide your secret access key. Similarly, you need to provide AWS region, and you need to provide your AWS region. Next, you need to provide your ECR repository URL, guys. Okay. So just replace your account ID here, guys. Okay. So this is your account ID. So just copy this account ID and just replace this account ID here. Okay. So let me come here. Just replace that account ID here and just copy this entire variable and paste it for ECR repository, guys. Similarly, you need to update EKS cluster name and you need to update EF state bucket. Okay. So right now I'm not going to update this everything because while I was testing this entire application, right, I just updated this everything. But you can just follow this CI/CD GitHub Actions secrets documentation, guys. Okay, so now let me open this .github/workflows and let me open this deploy.ml. Okay, so let me edit this and let me come down, guys. Okay, and here let me provide the third stage, and this is the third stage. Let me copy this entire stage. Now let me paste it here. Okay, so now let me select here commit changes, or else before doing commit changes, let me open ECR and let me show you the ECR repositories. In search bar, search for ECR and open this, and here you can see, let me select here repositories. So here you can see right now we don't have even single repository, right? So now this GitHub Actions pipeline will check for these three ECR repositories. So let me come here. So GitHub Actions pipeline will check for these three ECR repositories like Shopverse Frontend, Shopverse Backend, and Shopverse Helm chart repositories. So if the ECR repositories are not available, using our AWS IAM access key and secret key, it will create these three ECR repositories. Next, it is going to build this both Docker images like frontend and backend, and it will tag with the latest tag as well as with the GitHub SHA-ID, and it is going to push these two Docker images to the ECR repositories. Next, it is going to update helm values.ml file with the latest Git SHA-IDs, and it is going to install Helm. Next, it is going to log into our ECR Helm repository. Next, it is going to package our Helm chart. So basically, our Helm chart is located inside .helm/shopverse. So here you can see .helm/shopverse. Okay, let me drop down this. So this is the Helm chart, right? So it is going to package this Helm chart and it is going to put this Helm chart to the respective ECR repository, guys. Okay, so now let me select here commit changes, and let's see the output, and let me select here actions, and let me select here deploy.ml. Okay, so now here you can see we have three different stages. So the first stage is running, which is test. So let's wait for some time. And here you can see first stage is green. So now let me open the second stage, which is security scan. So currently it is building the front end Docker image. And here you can see security scan stage is also green. So now this is the third stage, guys. Okay, so here you can see right now it is configuring AWS credentials, so it's completed. Next, it is going to check for our ECR repositories. So here you can see it's created three ECR repositories, guys. Okay, so here you can see this is the Shopverse backend, and this is the Shopverse frontend, and this is the Shopverse Helm chart/Shopverse. Okay, so this pipeline has created these three ECR repositories, and it is building the frontend Docker image right now. So before that, let me open this ECR and let me refresh this. And here you can see it's created three ECR repositories, guys. Okay, Shopverse backend, Shopverse frontend, Shopverse Helm chart. Okay, so it's created these three ECR repositories. Now it's building the backend Docker image. So similarly, it will tag the Docker image with the latest Git ID as well as with the latest tag. And next, it is going to push this both frontend and backend Docker image to the respective ECR repositories, guys. Okay. Before that, let me open this frontend. So inside frontend repository, right now we don't have even single Docker image. And let me open this backend. So inside backend, we don't have even single Docker image, right? So after some time, we can see our Docker images, and here you can see right now it is pushing the backend Docker image, and here you can see it is updated image tags. So here you can see it is updated image tags inside helm values.ml file, guys. Okay, so let me come down, and pipeline is also green, guys. Okay, so it also pushed this helm chart to the ECR repository. Okay, so now let's check this everything. Let me open ECR, and first let me open the Shopverse hyphen frontend. So here you can see, we can see two Docker images. One is latest and one is with the 𝐻𝐫𝐶 ID, guys. Okay, so this is the frontend, and let me open the backend. And for backend, you can see latest image as well as with the GitHub SHA ID, guys. Okay, so this is the backend. Now let me check for the Helm chart. So you need to open the Shopverse hyphen Helm chart. So let me open this. So here you can see this is the Helm chart, guys. Okay, packaged Helm chart. So in the final stage, this Helm chart will be deployed to the EKS cluster, guys. Okay, so now this is about the third stage. Let me open this file. So now let's move to the final stage, which is provisioning infra and deploy. So basically this stage handles both infrastructure provisioning and the application deployment. So first it is going to authenticate with AWS using AWS IAM access key ID and the secret key ID. Next it checks if the EKS cluster is already exists by running EKS describe hyphen cluster command. So this is a conditional infrastructure approach. If the cluster exists, it skips straight to the deployment, and if it doesn't exist, it will provision entire infrastructure using our Terraform scripts, guys. Okay, so when Terraform runs, it initializes with a remote backend for state storage and generates a plan and next applies it. So this creates entire AWS infrastructure like a VPC, subnets, EKS cluster, node groups, IAM roles, and everything, guys. Okay. After Terraform finishes, it waits for both cluster and node group to be in active state using this command, which is AWS EKS wait command. Then next it is going to install AWS load balancer using Helm. So our cluster can create load balancers once the infrastructure is ready. And again, this is optional because we are using Traffic as our Ingress controller, guys. Okay. And next it is going to install kubectl and helm. Next it is going to update the kube config, and it is going to connect to our EKS cluster using this AWS EKS update hyphen kube config command, guys. Okay, so next it is going to log into our ECR repository, and it is going to deploy our helm chart, guys. Okay, so basically it is going to update this front end image with the git id, as well as it is going to update backend docker image with the git id. Next, it is we are going to pass this MySQL root password, MySQL password, and JWT secret from this GitHub secrets. So before running this pipeline, we need to provide this three fields, which is MySQL root password, MySQL password, JWT secret inside GitHub secrets case. Okay, so I will provide this three inside this GitHub README file. Let me go up and let me open the Shopverse, and let me come here. And here you can see, so we'll just update this dummy MySQL root password and MySQL password and the JWT secret. So you can use that JWT secret and MySQL password and MySQL root password, guys. Okay, so let me open this, and hyphen hyphen namespace, which is Shopverse. So it is going to deploy this Helm chart onto the Shopverse namespace. Okay, next we just provided hyphen hyphen time of 300 seconds, and here hyphen hyphen wait flag means Helm waits until all pods are in ready before making the deployment as successful. And here hyphen hyphen cleanup on fail flag automatically rollbacks if something goes wrong, guys. Okay, and finally it is going to verify all the resources. Like first it is going to verify the nodes, next it is going to verify the pods in the shop first namespace, and next it is going to verify stateful set inside the shop first namespace, and next it is going to verify service inside the shop first namespace, and similarly it is going to verify PV and PVC as well as secrets as well as ingress inside the Shopverse namespace, guys. Okay, so now before that, let me update these three secrets. So let me open GitHub secrets, and let me select here secret settings, and here let me open these secrets and variables, and let me select here actions, and here we need to search for MySQL root password. Okay, so this is the variable, guys. Okay, so let me edit this, So I'm providing MySQL root password as root @ 1234. Okay, so let's provide like this. So here you can provide whatever you want. So basically MySQL has a built-in root super admin account, and when the MySQL pod starts for the very first time in Kubernetes, it needs a password to set up for the root account, guys. Okay, so it's like setting up admin password when installing database, guys. Okay, so let me select here update secret. So similarly, let's update this MySQL password inside the secrets, and here you can see it's updated. So now let me update this MySQL password. Let me edit this. Okay. So let me provide MySQL password as app@123. Okay. So or else let me provide app@1234. Okay. So here our Go backend connects to the MySQL using a regular user called Shopverse, but not the root. And this will be the password for the user, and the backend uses this to log into the database and run queries, guys. Okay, that fetches products, create orders, and everything, guys. Okay, so let me update this secret. Now let me open this file, and finally we need to update this JWT secret. So this is the very important thing. So here you can see JWT secret. Let me edit this. Okay, so here you can provide any of the name. So let me provide like, sorry, so here let me provide like shoppers hyphen secret hyphen key hyphen 2024, something like this. I'm going to provide, guys. Okay, so the JWT secret is used when the user logins to the shoppers. The backend creates the JWT token and sends it back, and that token is signed using the secret key, guys. Okay. On every further request, the backend uses the same secret to verify the token is genuine and hasn't been trapped with any of the secret leaks, guys. Okay. So it must be kept very private, guys. Okay. So let me take this secret. Now everything is updated. So now let me open the Shopverse, and let me open this .github/workflows and deploy.ml, and let me edit this file, guys. Okay, so let me come down and let me update the final stage here. Let me go up. Let me copy this entire stage and let me paste it here. Before that, let me connect to the jump server and let me do kubectl get ns. So here you can see we don't have namespace with name Shopverse, right? So after some time, so if the pipeline is green, it will create a namespace called Shopverse and it will deploy this Helm chat to the EKS cluster, guys. Okay. So now let me select here commit changes. Now let me select here actions, and here you can see deploy.ml GitHub Actions pipeline is running, and here you can see provision infra and deploy stage is added. And let me open this test, and here you can see it is running a few of the test cases. So let's wait for some time. And here you can see all the three stages are green. So now it is running the final stage, which is provision infra and deploy. So basically in this stage it is not going to provision the infra. So first it will check the EKS cluster is available or not. If the EKS cluster is available, it will skip all the stages, guys. Okay, so here you can see EKS cluster is found. So that is the reason why all the stages were skipped. So now currently it has logged into the ECR repository, and here you can see it has updated the kube config also, and currently it is deploying the Helm chart inside our EKS cluster, guys. Okay, inside the Shopverse namespace. So let me come here, or else let's wait here for some time. So here you can see deployment has been completed successfully. And let me come here. So here you can see final stage is also green, guys. Okay. So our Shopverse Helm chart has been deployed successfully. So first it will check whether the Shopverse Helm chart is available or not. So if the Helm chart is available, just it is going to upgrade the Helm chart, or else if the Helm chart is not available, it is going to install the Helm chart, guys. Okay. So this is the very first run, right? So that is the reason why Helm chart has been installed inside our EKS cluster. So from next runs, it is going to just upgrade the Helm charts with the latest Docker images, guys. Okay. So now here you can see it has verified everything. So these are the two nodes, and here you can see these are the pods are running. So these are the two backend pods, Shopverse backend pods, and this is the two Shopverse frontend pod, and this is the MySQL pod. This is basically the MySQL stateful set pod, guys. Okay, so this is the stateful set, and this is the backend service, and this is the front end service, and this is the MySQL stateful set service, and this is the persistent volume, and this is the persistent volume claim. And here you can see right now we don't have any ingress, so that is the reason why it's not showing anything. And finally the job is green. So now let's verify this everything by connecting to the jump server. So now here you can see right now it is showing only, previously it is showing only four different namespaces, right? So now we need to see shop first namespace. Let me do kubectl get an s, and here you can see shop first namespace has been created last 2 minutes 38 seconds ago. Before that, let me check for the Helm chart. Let me do Helm ls -a. So if you do Helm ls -a, it will display all the Helm charts in all the namespaces, guys. Okay. So if you want to display only the namespace which are available in the shop as namespace, so you can run this command helm ls -n and directly provide the namespace name which is Shopverse. Okay. So here you can see this is how you can get. Okay. So if you hit a -a, it will display all the Helm charts and all the namespaces, guys. Okay. So now if you want to see the status, you can directly run this command helm status Shopverse -n Shopverse, guys. Okay. So basically it will display the status. So here you can see name is Shopverse. So last deployed on March 24th, and namespace it deployed on the Shopverse, and status is deployed. So currently revision is 1. Okay. So now let me do kubectl get all -n Shopverse. So inside Shopverse namespace, we need to see everything. So here you can see these two are the backend pods. So it's running without any issues. So these are the front end pods. It's running, and this is the MySQL stateful set pod, guys. Okay, and this is the backend service, and this is the front end service, and this is the MySQL stateful set service, and this is the backend deployment, and this is the front end deployment, and this is the backend replica set, and this is the front end replica set, and this is the MySQL stateful set, guys. Okay. So a part of this, we are also creating config maps. kubectl get cm-n shop first, and here you can see shop first config. So basically, this is the config map. So let me copy this name kubectl edit config map, and let me provide the name of the config map -n shop first. So basically, this is the namespace name. And inside this config map, we are storing DB host, DB name, DB port, and DB user, guys. Okay. And this is the front end origin, guys. Okay. So now let me exit from this. And we are also creating secrets. So kubectl get secrets -n shopverse. So basically, all these resources were created using Helm chart, guys. Okay, so that is the power of Helm chart. So in my previous video, I already explained you about Helm. Let me open this YouTube. Let me show you that video, and let me search for my YouTube channel, which is 𝐩𝐫𝐸𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻𝐵𝐻 And here you can see, guys, so I created an end-to-end playlist on Kubernetes. So basically, if you want to learn Kubernetes, you can follow these videos, guys. Okay, you can directly open this playlist, and here you can see this is the Kubernetes playlist. Nearly I posted 41 videos, guys. Okay, so if you want to learn Kubernetes, you can just follow all these videos. Also, I created Helm in one shot, so you can directly watch this video, guys. Okay, so if you want to learn Helm, so let me close this. So this is the secret, right? So let me copy this. Now kubectl edit secret, and let me provide the secret name. And now let me provide the namespace name, which is Shopverse. And here you can see inside secrets, we are storing DB password, JWT secret, and MySQL root password, guys. Okay. So now let's connect to the MySQL database. Let me come out from this, and let me open this GitHub repository, and you can follow this GitHub repository to connect to the MySQL database also, guys. Okay, so you can directly come down, and here I have just written everything. So here you can see get the database password. So initially you need to get the database password. So you can directly get the database password by running this command, or else you can directly come here and just run this command kubectl edit secret, and you need to provide the secret name, and you need to provide the namespace name. And next, copy this db password, copy this password, and come out from this and echo, and copy that base 64 encoded password, and base 64 hyphen decode, guys. Okay, and here you can see this is the password app at the rate 1234, and basically we are passing all these database password, jwt secret, and mysql root password from GitHub Actions pipeline itself, guys, dynamically. Okay, so basically we are storing these secrets inside this GitHub secrets, guys. Okay, so this is the one of the main advantage. We are not going to hard code inside the GitHub repository. We are storing inside GitHub secrets, and while running this pipeline, we are dynamically passing these secrets to the Helm chart, guys. Okay, so this is one of the real-time use case. So now let me come here. So now you can directly run this command. So this is the second option to get the password, guys. Okay, so let me paste it here, and here you can see app at the rate 1234. Okay, so this is the db password. So now let's connect to the database. So basically we are going to connect to mysql shell. So first it is going to connect to the mysql stateful set pod. So this is the mysql stateful set pod name. So if you want to see that, you can directly do kubectl get sts. If you do sts, it will display all the stateful sets, guys. Okay, so now let me do hyphen and shopverse. It will display stateful set inside the Shopverse namespace. Okay, so here you can see Shopverse hyphen MySQL. Now let me do kubectl get pods hyphen n Shopverse. It is going to display all the pods inside the Shopverse namespace. So basically this is the pod name. Okay, Shopverse hyphen MySQL 0, and here you can see Shopverse hyphen MySQL 0. So basically this command will connect to the MySQL pod, and after that it will connect to the MySQL shell, guys. Okay, so let me copy this command, and let me paste it here. Now it will connect to the MySQL shell, guys. Okay, so now you can run all these commands to see all the tables. You can see all the registered users. You can see all the products. And if you want to see all the products grouped by category, you can run all these commands, guys. Okay, so first let's see all the tables. Let me copy this command, and let me clear the screen, and let me paste it here. It will display all the tables. So currently we have these 5 tables, which is cart items, orders, products, and users. So basically this application will work similarly like a real-time application, but this is not a real-time application, guys. Okay, so if you are a fresher, you can directly do this project, and you can directly keep this project inside your resumes, and you can directly explain to the interviewer also, guys. Okay, so now let me come here, and if you want to view all the registered users, you can directly run this command, guys. Okay, so let me paste it here. It will display all the registered users. So right now we don't have even single registered user, so that is the reason why here it is not showing even single registered user, guys. Okay, so now if you want to view all the products inside the Shopverse application, you can directly run this command. So let me paste it here. So here you can see these are all the products available inside our Shopverse namespace, guys. Okay. So basically these are all the products for electronics. These are all the products for clothing, and these are the products for accessories, and these are the products for food and drinks, and these are the products for sports, and these are the products for home and living, guys. Okay. So now if you want to view products grouped by category, you can directly run this command. Okay. So let me paste it here. And here you can see in Shopverse namespace, total electronics, we have 7 products, and this is the average pricing, and this is the minimum pricing, and this is the maximum pricing. Okay. And for accessories, we have total 5 products, and clothing, we have 4 products, and food and drinks, we have 4 products, and home and living, we have 4 products, and sports, we have 4 products, guys. Okay. So these are the average pricing, and this is the minimum pricing, and this is the maximum pricing, guys. Okay. So now let me come here. So if you want to view all orders with customer info, you can directly run this query, guys. Okay. So right now it will display empty set because we haven't created any user yet, guys. Okay. So now let's try to access this UI. Before that, to access this UI, you need to install Traffic Ingress controller, guys. Okay. Not only Traffic, you can install Istio Ingress, or else you can go with Gateway API, or else you can go with AWS Load Balance Ingress controller. But in this video, especially I'm going with the Traffic as our Ingress controller, guys. Okay. So let me do kubectl get all hyphen n shoppers. So here you can see front end service. We are using node port service, but I'm not going to access this application via node port. I'm going to access via traffic ingress controller DNS name, guys. Okay. So now let me install traffic inside this EKS cluster. So you can directly follow this documentation, guys. Okay. So directly jump onto docs and open this traffic on EKS, and you can directly run all these commands, guys. Okay. So already we just connected to the EKS cluster, so you can leave these commands. So now we need to install traffic via Helm. So let me copy this. So basically we are going to add traffic Helm repository to the EKS cluster, guys. Okay. So let me do Helm repo ls, and here you can see we don't have even single Helm repository. So now I'm going to add this traffic Helm repository. Now let me do Helm repo ls, and here you can see traffic Helm repository has been added successfully. Now I'm going to create a namespace called traffic. Let me copy this. Before that, let me do kubectl get ns grep traffic, and here you can see with traffic namespace we don't have even single namespace. Let me create a namespace called traffic, and let me run this command once again. Now here you can see traffic namespace has been created successfully. So now I'm going to create a custom values.ml file to install this traffic. Let me do vim traffic hyphen values.ml, and let me keep this in insert mode, and let me copy this entire values file, and let me paste it here, guys. Okay. So basically service type we are going to create with type load balancer, and we are going to pass all these 3 annotations, which is AWS load balancer type we are going to create with network load balancer, and AWS load balancer schema we are going to create with network internet facing, and AWS load balancer cross zone load balancing enable. So we are going to enable this cross zone load balancing, guys. Okay. And basically we are going to expose these ports, guys. Okay. So now let me save this. Let me clear the screen and cat traffic hyphen values.ml. Okay. So now let me come here, and we are going to install traffic using this values.ml file, guys. Okay. Helm upgrade hyphen hyphen install traffic, and traffic slash traffic and hyphen hyphen namespace traffic. We are going to install this traffic inside the traffic namespace, and we are going to use this custom traffic values.ml file which we have created earlier, guys. Okay. So now let me copy this command. Let me come here and let me paste it here. Now let me come here and let me select here EC2. Now it will create a load balancer, guys, in background basically. Okay. Let me select here load balancers. Okay. So here you can see it's already in provisioning state. So let me come here, and here you can see it's deployed successfully. So now Let me do helm ls -n traffic. So we installed this traffic helm chart inside the traffic namespace. So that is the reason why here you need to provide namespace name, guys. Okay. Or else if you want to list all the helm charts, you can directly run this command helm ls capital A. Okay. It will display all the helm charts in all the namespaces, guys. Okay. So here you can see shop first namespace. Sorry, shop first helm chart and traffic helm chart. Okay. So now let me check all the resources inside traffic namespace kubectl get all -n traffic, and here you can see traffic pod is running and it's created service type with load balancer, and this is the load balancer DNS name, and this is the deployment, and this is the replica set, guys. Okay, so now let me come here. So additionally, if you want to access traffic dashboard, let me come down. I just provided few of the commands to access traffic dashboard. So if you want to access traffic dashboard, you can directly copy this command. You can directly port forward the service case. Okay. So you can directly access the traffic dashboard also. But in this video, I'm not going to access the traffic dashboard. So now let me create ingress routes for the front end and back end services. So here you can see we are going to create ingress route. So in the namespace called Shopverse, and first we are going to create ingress route for the backend, and we are going to pointing to the service which is Shopverse backend service. Okay, so let me come here and let me do kubectl get service -n Shopverse, and this is the backend service, guys. Okay, Shopverse backend service. So basically we are going to create this ingress route for the backend service, and we are going to create this ingress route for the front end service, guys. Okay, so before that, let me run this command. So here you can see right now we don't have even single ingress route. Okay, so now I'm going to create these two ingress routes for the front end and back end services. Let me paste it here, and it's created. Now let me run this command kubectl get ingress routes -n shop first, guys. Okay, so basically it will display both the ingress routes inside the shop first namespace. Okay, and here you can see it's created successfully. So now let's try to access our Shopverse application using this load balancer DNS name, guys. Okay, let me refresh this. Here we need to see active. Okay, so now using this load balancer yeah, sorry, DNS name. So this is the DNS name. Okay, so using this DNS name you can directly access the Shopverse application, guys. Okay, so let me open a new tab and let me paste it directly, and here you can see this is the final output of our project, guys. Okay, so now let's test this application. So initially you need to create a user account. So here you can see basically you need to create a account. So let me provide account name as Vijay, and you can provide any of the email, guys. Okay, let me provide vijay@gmail.com. Let me remove this gmail.com. Okay, now password vijay@123. Okay, so I'm going to provide this. So initially you need to create an account. Okay, so now let me connect to the database. Let me open this and let me select here Shopverse, and let me come down. Okay, so now let me connect to the MySQL shell, guys. Okay, so let me run this command. So basically we are going to connect to the MySQL stateful set pod, and from that pod we are going to connect to the MySQL shell, guys. Okay, so now let me run show tables. It is going to display all the tables. Okay, so right now we created a user called Vijay, right? So now let me do select star from users. So here you can see Vijay user has been created successfully, guys. Okay, so this is how you can see everything. So now let me run other command. Let me come here. So view complete order breakdown. So let me copy this command and let me paste it here, guys. Okay. So here you can see right now from Shopverse application, even single user haven't ordered anything, right? So now let's do one thing. Let's order few of the products from the Shopverse application with user Vijay. So you can directly select your products. So you can find multiple products. So if you want to see only electronics, you can directly select here electronics. So it will display only electronic guys. Okay. So similarly, clothing, it will display only clothing. Accessories, it will display only these five accessories. And food and drinks, it will display only these four items. And sports, it will display only these four items. And home and living, it will display only these four items, guys. Okay. So in all, you can display, you can see all the products in this Shoppers application. So now in electronics, I will add this headset, and from accessories, I will add this bag, and I will open this cart. So inside my cart, I have these two items, right? So I will order these two items, guys. Okay, place order. So here you can see order has been placed, right? So total amount is 129 USD. So now let me come here and let me rerun that command once again, guys. Okay. So now here you can see Vijay has ordered these two items, which is canvas laptop pack and wireless noise cancellation headphones, guys. Okay. So this is the pricing. So this is how it will update this entire tables, guys. Okay. So now basically this application will work like a real-time application, guys. Okay. So now let me come here. So if you want to view current cart items for all the users, you can directly run this command, guys. Okay. So let me paste that command here, and here you can see right now it is showing empty set, right? So now I will come here and I will add few of the products to the cart case, but I will not order. Okay. So I will add this product, and let me add this product, and let me add this product. So we just added three items to the cart, right? So now let me come here and let me copy this command. So basically this command will display all the cart items from all the users guys. Okay. So let me clear the screen and let me run this command. And here you can see Vijay has added these three items to the cart. Okay. So similarly, we just added three items, right? So here you can see these are the three items. So it is displaying these three items here. Okay. So now let me run this command, but we haven't ordered these three items, right? Just we ordered two items. So if you want to see the two items, you can directly run this query. So it will display these two items. Okay. So now if you want to order this, you can directly view cart and place order. And here you can see order has been placed successfully. So this is the order one and this is the order two. Okay. So in order one, we just ordered two items. In order two, we just ordered three items, right? So now let me run this command, and here you can see it is displaying five items, guys. Okay. So Vijay has ordered these five items. So now let me see the cart items. So now our cart items is zero. Okay. So here you can see inside our cart we don't have even single item, right? So now let me paste this command here, and here you can see cart is empty set. So now if you want to create second user, you can directly log out from this and directly select here sign in, and you can directly select here don't have an account, sign up, and you can directly provide name like another name like Naresh, and email naresh@gmail.com, and Naresh@123, guys. Okay. Select create account. So now it will create a new account, guys. Okay. So here you can see Naresh account has been created, but I haven't ordered anything. So now let me do show tables, and let me do select star from users. And here you can see Naresh user has been created, guys. Okay. So now let me add few of the items to the cart. Let me add this item, and let me add the shoes. Now let me check the current cart items. So we need to see cart items for Naresh here now. And here you can see Naresh has added these two items. Now, if you want to see all the ordered items, you can directly run this command. You can directly paste this command. It will display all the order details for all the users case. Okay. So only Vijay has ordered this item, right? So now Let me go to the cart and let me place this order, and order has been placed, right? So now we need to see Naresh orders inside this table, guys. Okay, so let me run this command. So here you can see Naresh user also has ordered these two items, guys. Okay, so this is how you can see everything. So if you want to see the dashboard summary, you can directly run this command, guys. Okay, so basically it will display the dashboard summary, something like this, like total users is 2, total products is 28, total orders is 3, something like this it will display, guys. Okay, so from Shopverse we have this total revenue. Okay, so this is how it will display everything. So now let's exit from this database. Okay, so now let me come here, let me open this shop first and let me select this. Okay, so now let's set up DNS access for this application. So currently we are accessing this application using this load balancer DNS name, right? So now let's access this application via a domain name, guys. Okay, so let me open GoDaddy. So already I have a domain name inside GoDaddy, so I will use the domain name, guys. Okay, so let me cancel this and let me select here my products and let me select here DNS. Okay, so now let me come here and let me search for route 53 and let me open this in a new tab. And here we need to create an hosted zone, guys. Okay, so this is the first step. Let me create a hosted zone. Create hosted zone. So basically this is my domain name, which is vijaygiridhuri.in. So I will use this domain name to create route 53 hosted zone. Okay, and type you need to select here public hosted zone and directly select here create hosted zone. Okay, so now hosted zone has been created, right? So now we need to update these four name servers with the GoDaddy name servers, guys. Okay, so these are the four name servers. So let me open this and let me select here name servers and change name servers. And here we need to select I'll use my own name servers, and here you need to provide your route 53 four name servers, guys. Okay, so this is the first name server. Let me paste it here, and this is the second name server, and directly select here add name server and copy the third name server and directly select add name server and copy the fourth name server and paste it here, guys. Okay, so let me cross check this. So the first one is one NS1667. So the first one is NS1667 and the second one is NS545, NS545, and the third one is NS1303, and the fourth one is 374, guys. Okay, NS1303, NS374, guys. Okay, everything is okay. So directly select here save. So now to update this DNS, it will take around 5 to 10 minutes. Sometimes it will take more than 1 hour, guys. Okay, and sometimes it will take more than 1 day also, guys. Okay. So let me select here name servers. It is not displaying anything. Let me refresh this entire page. And okay, so these are our AWS Route 53 name servers. It has updated successfully. So now you need to create a record, guys. Okay, that needs to point to this network load balancer. So now directly select here create record and type you need to select here a record, and here you need to enable this alias, and here you need to select endpoint, which is network load balancer. So here is the network load balancer. So here you can see alias to network load balancer. So here region you need to select this region, which is US East one and which is North Virginia. And let me select here North Virginia. Okay, US East one. Okay, so this is the region. So here you can see our network load balancer, guys. Okay, so this is the one you need to select and directly select here create record. Okay, so let me check the status. So currently here it is showing pending, right? So here we need to see something like active. Okay, so meanwhile let me open DNS propagation checker. Let me open this first one. Let me search for vijay-git3.in and a record. Okay, in some regions it is updated successfully. Let me check in India. Okay, 216.124. And here you can see in sync. Okay, so we need to see this message inside route 53. Let me select here vijay-git3.in. Okay, record also has been created successfully. So now let's try to access our Shopverse application using our domain name. So right now we are currently accessing our load balancer DNS name, right? So now I'm going to access this application using my domain name, which is vijay-git3.in, guys. Okay, so let me open incognito window. This will be better. http:// vijay-git3.in. Okay, let me hit enter, and here you need to select continue to site. Meanwhile, let me try to access here also, guys. Okay, so let me open this http:// vijay-git3.in. Okay, and it is showing this IP address, guys. Okay, so let me refresh this once again. Let me reload this. So now here you can see we can successfully able to access the Shopverse application using this domain name, which is vijay-git3.in, guys. Okay, so it has taken nearly 30 minutes to update these DNS records. So now let's try to sign into the existing users, which is Vijay and Naresh. So before that, let me come here and let me open the GitHub repository. Let me keep it here. Okay, so now let me open this GitHub repository. And let me connect to this MySQL Cloud Shell once again. Let me paste it here. Now let me do show tables. It is going to display all the tables. And let me do select star from users. It is going to display all the users for the shopper's namespace. So basically we have two different users. One is Vijay and Naresh. So let me connect to Vijay user, vijay@gmail.com. So this is the email I just provided, and password vijay@123 I just provided. Okay, so here you can see we can able to log in. So this application is working fine. So let me log into the Naresh user. So naresh@gmail.com, and the password is naresh@123, guys. Okay, let me select here sign in. So never. Okay, so we can able to access to the Naresh user, and let me select the cart items. Okay, so this is the orders details for Naresh. Okay, so this application is working fine. So now if you want to create third user, you can directly select here sign in, and you need to select here don't have an account sign up, and Shravani, and Shravani@gmail.com, and Shravani@123. So basically this is the password. Okay, so account has been created. So but she haven't ordered anything, right? So now let's order some shoes and foods and drinks. Let's order some chocolate, dark chocolate. Okay, in electronics let's order this watch. Okay, and view cart details. So currently we haven't ordered this, but we just added these three items to the cart, right? So now if you want to see all the users cart list, you can directly come here and you can directly run this query, guys. Okay, view ordered items by the product, not this current cart item. Okay, so you can directly run this query. So here you can see Shravani user has added these three items to the cart. Okay, so now let me place this order. So order has been placed, right? Now inside this cart we don't have a even single item, right? So now let me rerun this command. So here you can see empty set. Okay, so now let's see all the users order details. View orders with product items. Okay, so let me copy this command and run this command. Okay, sorry, not this. Let me go up. Let me run this command, guys. Okay, so basically it will display everything, and here you can see Vijay has ordered 5 items, Naresh has ordered 2 items, and Shravani has ordered 3 items, guys. Okay, so this is how you can see everything. And if you want to see the dashboard summary, you can directly run this command, guys. Okay, and here you can see now total users is 3, total products is 28, and total orders are 4, and total revenue from Shopverse application is 605, guys. Okay, so this is how it will display everything. So now let me open this Shopverse application. So currently we are accessing the Shopverse application using HTTP, right? So right now it is not secure. So now let's set up HTTPS using set manager and let's encrypt. Before setting up HTTPS, first let me explain you why HTTPS. So without HTTPS, all traffic between the user's browser and our application is unencrypted. Browser shows not secure, something like this. And basically this is the warning, and sensitive data like login credentials are exposed, and HTTPS encrypts everything using SSL and TLS certificates, guys. Okay, so now let me explain you about Let's Encrypt. So basically it's a free and automated certificate authority, CA, that issues SSL and TLS certificates, guys. Okay, and these certificates are valid for 90 days, so you can auto renew whenever you want. Okay, so let me open this GitHub repository, and you need to navigate to docs folder, guys. Okay. So inside docs folder, you can find documentation to set up traffic on EKS. So similarly, if you want to set up HTTPS connection, you can directly follow this HTTPS setup README file, guys. Okay. So let me open this. So before that, first we need to install Set Manager. So before installing this, let me explain you about Set Manager. So basically, it's a Kubernetes native tool that automates requesting and issuing and renewing certificates from Let's Encrypt. Without Set Manager, we would have to manually run setpod for every 90 days, guys. Okay. So first let's install this set manager. So basically when we install this, this deploys 3 pods. One is controller and the second one is CA injector and the third one is webhook in a dedicated set manager namespace using Helm, guys. Okay. And the controller watches for certificate resources, and it handles the issuance process, guys. Okay. First let me copy this command to add this jetstack helm chat. Before that, let me exit from this MySQL shell. Now let me do Helm repo ls. So right now we have only traffic Helm repository, right? So now this jetstack repository will be added. Now let me do Helm repo ls. So here you can see now we have traffic Helm repository as well as jetstack Helm repository. So now I'm going to install this set manager Helm chat. Let me come here and let me paste it here. So basically it will install inside namespace called set manager, guys. Okay. So now it will create a namespace called set manager. So inside that set manager namespace, it is going to install this everything, guys. Okay. So after installing this, we need to install this cluster issuer. So basically this tells set manager where to get certificates from. We configure it with Let's Encrypt production server and our email, which is vijay.gidturi@gmail.com. So this email is used for expiry notifications and account recovery. We will use HTTP 01 resolver. which means let's encrypt to verify domain ownership over HTTP, guys. Okay. So meanwhile, let me copy this command and let me open this. So here you can see it's deployed successfully. Now let me do kubectl get ns. It will display all the namespaces, guys. Okay. And here you can see set manager namespace has been created last 75 seconds ago. Now let me do kubectl get pods hyphen and set manager. And here you can see inside set manager, all the three pods are running as I said. Okay. So this is the CA injector and this is the webhook and this is the set manager. Okay. Now let me come here. Let me create cluster issuer. Let me paste it here. And one thing you need to remember here, just provide any of the email, guys. Okay, so you can provide any dummy email, that is not a problem. In even this is a dummy email, guys. Okay, so you can provide your proper email address also, that is also not a problem, guys. Okay, so let me run this command kubectl get cluster issuer. So you need to see status as ready, guys. Okay, let me paste it here. Now ready status is true. Okay, so if you want to describe this, you can directly copy this kubectl describe cluster issuer and provide the name base directly. Okay, this is the name. Let me remove this and let me paste it here. And it will display detailed information about this cluster issuer. Okay, so now let me open this readme file. So now let's create certificate. So let me copy this or else before creating this certificate, let me explain you about this. So basically this tells set manager what domain needs a certificate. In our case, which is vijay-git3.in. So for this domain, we need a certificate. So next it creates a certificate request and next it is going to create an order and next it is going to create a challenge. So once if it's verified, let's encrypt issues the certificate. And next, Threat Manager stores it in a Kubernetes secret called Shopverse TLS secret, guys. Okay, so it is going to store inside this Shopverse TLS secret. Let me show you that. Let me copy this command and let me paste it here. So okay, it's created successfully. So now you need to run this command kubectl get certificates hyphen and shopverse. So because we created inside the shopverse namespace, guys. Okay, so here you can see namespace equal to shopverse. So now let me come here and let me paste it here. And here you can see it's created last 17 seconds ago. So but we need to wait till it's in the ready state, guys. Okay, so basically it will take around 2 minutes of time. So let me do hyphen watch. So let me describe this first. Let me copy this. Let me come here. Let me paste it here, guys. Okay. So it will display detailed information about this certificate. Okay. So here you can see you can find in detailed information, guys. Okay. Issuing certificate as a secret does not exist. Storing new private key in temporary secret resource. So basically these are all the events. You can see events, guys. Okay. So here you can see the certificate has been successfully issued. It is telling, let me do kubectl get certificates hyphen and Shopverse. Okay, it is still showing true. Okay, no problem. If you want to get certificate request, you can directly run this command, guys. Okay, so have documented everything in a proper way. So basically this is the certificate request. And if you want to see orders, you can directly copy this command and you can directly paste it here, guys. Okay, and here you can see it's valid, it's showing. Okay, so now finally we need to create HTTPS ingress route. So basically we are accessing using HTTP, right? So here you can see we are accessing using only HTTP. It is not secure. Now we are going to create update our ingress routes using HTTPS, guys. Okay, so you can directly copy this and you can directly run this command here, guys. Okay, so basically it will update existing YAML files with HTTPS, guys. Okay, so now let me do kubectl or else let me come here. Okay, let me come here. let me try to access with https colon slash slash vijay-gidithuri.in, and we need to access our application with https, guys. Okay, so now here you can see we can able to access our application with https, guys. Okay, let me try to access here also https colon slash slash vijay-gidithuri.in, and here you can see now connection is secure, guys. Okay, so certificate is valid and this is the certificate, guys. Okay, so this is how you can set up https connection to your Shopverse application. Now let me come here. Now let me explain you about this http to https redirection. So basically, this creates a traffic middleware that permanently redirects to 301, and all HTTP traffic redirects to HTTPS, guys. Okay, and if someone visits at HTTP colon slash slash vijay-gidithuri.in, something like this, it will automatically redirect to HTTPS, guys. Okay, so that request will automatically forward to HTTPS if you create this one. Okay, so now I'm going to create this. Let me come here and let me paste it here. Okay, let me come here. Okay, it's created successfully. So now let me come here. Okay, we can able to access via https, right? Let me check in the command line also, guys. Okay, let me paste it here. Okay, now let me try to access with http. It needs to redirect to https, guys. Now, okay. Okay, so here you can see it is redirecting to HTTPS, guys. Okay, so 308 permanently redirect, which is HTTPS. So currently we are trying to access with HTTP, but it is redirecting to HTTPS, guys. Okay, so now let's do one thing. Let's close this and let's try to access with HTTP, guys. Okay, which is vijay-gidithuri.in. It needs to redirect to HTTPS, guys. Okay, so here you can see redirection is also working fine. Okay, so now connection is secure and this is the certificate we are accessing with HTTPS, guys. Okay, so from now if any user is trying to access our application with HTTP, it will automatically redirect to HTTPS, guys, something like this. Okay, so here you can see I'm trying to access with HTTP colon slash slash vijay-gidithuri.in. It is automatically redirecting to HTTPS, guys. Okay, so here you can see HTTPS and the connection is also secure, guys. Okay, so connection is secure and this is the valid certificate. Okay, and this certificate will expire after 90 days. Okay, so you can auto renew, guys. Okay, so now finally let's test this application end to end by creating another two users. So let me exit from this. Before that, let me connect to the MySQL shell and let me come down and let me copy this command, guys. Okay, so it will connect to MySQL shell. Now let me do show tables and select start from users. Okay, so currently we have three users, right? So let's quickly create another two users. Let me select here sign in. Now let's create a user like saibaba@gmail.com. Okay, so password saibaba@123. Okay, so Saibaba has been created successfully, but he haven't ordered anything, right? So now let's order food and drinks. Let's add this chocolate and let's add this drink. Okay, so now if you want to see cart list for all the users, you can directly run this command, guys. Okay, this is the command. Okay, you can directly paste it here. Now here you can see Sai Baba user has added these two items to the cart. Similarly, if you order this item, right, it will move from the cart. So now order has been placed, right? So now if I run that command once again, and here you can see empty set. So now if I uh, try to run this command, view order items and product details, not this complete order breakdown. Okay, this command, it is going to display all the orders, guys. Okay, so here you can see Sai Baba orders has been showing here. So similarly, let me add another user, Sarada, and sarada@gmail.com, sarada@123. So Sarada user has been created successfully. So now let's order only single item base. Okay. So let's order this mechanical gaming keyboard, and let's add this camera. Let's add this, or else let's add four items. Okay. Let's add this watch also guys. Okay. So total we have four items in the cart. So now let me run this command. Okay. Not this command, cart items. Okay. So this command. So now we need to see four items. So here you can see four items. This user has said the user has added these four items to the cart, guys. Okay. So now I'm going to order these four items. Place order, and here you can see order has been placed successfully. And this is the insights are the user. These are the four items, guys. Okay. So now let me come here and let me run this command. It will display all the orders from all the users, guys. Okay, so here you can see Vijay has ordered 5 items, Naresh has ordered 2 items, Shravani has ordered 3 items, Sai Baba has ordered 2 items, and Sharda has ordered 6 items, totally 4 items, guys. Okay, so these are all the orders. So finally, if you want to see this dashboard summary, you can directly run this command, guys. Okay, and total users is 5, total products ordered is 28, and total products is 28, and total orders are 6, and this is the total revenue from the Shopverse application, guys. Okay, so this is how you can see everything. So now let me open this GitHub, and let me open this .github/workflows and deploy.ml. So finally, let me give you an overview of this GitHub Actions pipeline. So basically, this pipeline is designed to be fully automated end to end. So when a developer pushes code to the main branch, so within minutes, it tested, scanned, and built and deployed it to our EKS cluster with zero manual intervention, guys. Okay, so this is the main advantages of using CI/CD pipelines. So let me do a small modification. So I'm not going to modify any of the code base, but let me modify this readme file, guys. Okay, so automatically this GitHub Actions pipeline will trigger, and it will upgrade the Helm chart with the latest Docker images, guys. Okay, so let me come down, and let me uh, add these spaces, and let me commit these changes. Okay, so now here you can see within seconds this GitHub Actions pipeline will start, guys. Okay, imagine developer has pushed some changes to the GitHub repository, and this GitHub Actions pipeline is triggered. Okay, so here you can see right now test is running. Meanwhile, let me exit from this database, and let me do kubectl get pods -n shop first. And here you can see these pods are running from last 98 minutes, right? So after some time, these pods will be redeployed with the new images, guys. Okay, in the final stage. Okay, so I will show you that everything. So now this application is end-to-end automated, guys. Okay, so from now, if any developer has pushed this code to the GitHub repository, that means if any developer changes that code in the GitHub repository, automatically this pipeline will trigger, and it will deploy that latest changes to the stage, guys. Okay, here it will reflect everything. Okay, so let me come here. So let's wait for some time, and here you can see security scan is going on. And once again, let me do kubectl get port f9 shop first, and it's running from last 99 minutes, right? So after some time, these pods will be recreated, guys. Okay, And here you can see all the resources were deployed once again. So pipeline has deployed with the latest changes, like with the latest image IDs. So pods are recreated. So now let me come here, and here you can see earlier it is running from last 99 minutes, right? So now let me do kubectl get pods hyphen and shoppers. So here you can see backend and front-end pods are running from last 50 seconds, guys. Okay, so this is how this Helm chart will upgrade using this GitHub Actions pipeline. Let me do Helm ls hyphen n shoppers. It will display shoppers Helm chart. So here you can see revision is 2. Let me do Helm status hyphen n shoppers. Shoppers and hyphen and shoppers guys. Okay, so here you can see now revision is 2. Earlier the revision is 1 guys. Okay, so this is how it will redeploy all the resources guys. Okay, so now here you can see, so the pipeline is also green, entire resources were deployed. Helm chart is deployed with the latest changes guys. Okay, so earlier in the very first stage it is installed, so now it's upgraded guys. Okay, because first it will check whether the Helm chart is installed or not. If it's not installed, it will install. If it's installed, it will just upgrade the Helm chart with the latest changes guys. Okay, that's it. Okay, so and yes, that's it for this today's video. So after completing your labs, try to delete all these resources guys. Okay, so simply you need to come here and you need to do terraform destroy. That's it, all the resources will be destroyed guys. Okay, so now I'm going to destroy this entire application. So now let me log out from this. Okay, so now let me come here and let me do Terraform state list. It will display all the created resources guys. Okay, so here you can see these are all the resources which is created by Terraform, right? So now I'm going to do Terraform destroy hyphen auto hyphen appro. Okay, so now it is going to destroy all the resources which is created by Terraform guys. Okay, these jump servers, EKS clusters, NAT gateways, internet gateways, VPC subnets, all the resources will be destroyed from now guys. Okay, so manually you need to delete two resources. One is uh, Route 53 hosted zone, and the second one is IAM access keys and secret keys guys. Okay, so this is optional, you can keep, but I just exposed my IAM access key and secret key, right? So that is the reason why I was just deleting these two resources. So now let me jump on to Route 53. First we need to delete this a record, delete record, delete. Next we can directly delete this hosted zone. Okay, so let me select this hosted zone, delete and delete. Okay, so now this will not work guys. Okay, so here you can see this site can't be reached. So let me close this, let me come here. Okay, so I just deleted this out 53. Let me jump on to GoDaddy and let me change this to GoDaddy name servers. Okay, I just changed this to GoDaddy name servers and let me select here continue. Let me refresh this page. Okay, because here we need to see GoDaddy name servers. Okay, so these are my GoDaddy name servers. Let me close this. Now let me jump on to IAM. Let me select here done, continue. Okay, so after deleting these resources, I will delete this IAM access key and secret key guys. Okay, because right now it is destroying these resources, right? So after deleting all these resources, I will delete my IAM access keys and secret keys guys. Okay, so and yes, that's it for today's video. And if you like my video, please do like, share and subscribe to my YouTube channel, and see you in the next video, and bye.